National Electrical Code requirements for ranges with a gas top and an electric oven state that a 30-amp circuit is suitable for ranges with a total electrical load of 8,000 watts or less, while a 40-amp circuit is required for ranges with a total electrical load exceeding 8,000 watts. To determine the circuit size required, consult the manufacturer's specifications or the nameplate of the appliance. The nameplate will indicate the total wattage of the range. For ranges less than 8,000 watts, a 30-amp circuit is sufficient. Use 10 American wire gauge wire with a 3-pronged NEMA 14-30 receptacle for the connection. For ranges greater than 8,000 watts, a 40-amp circuit is required. Use 8 American wire gauge wire with a 3-pronged NEMA 14-50 receptacle for the connection. The circuit should be dedicated to the range only and not shared with other appliances. A ground fault circuit interrupter or arc fault circuit interrupter may be required by local building codes. It is recommended to consult with a qualified electrician to ensure proper installation and adherence to code requirements. When dealing with electrical installations, safety and adherence to the National Electrical Code are paramount. This discussion focuses on the electrical requirements for ranges that combine a gas cooktop with an electric oven, a common appliance configuration in modern kitchens. Understanding the correct circuit size and wiring is essential to prevent hazards and ensure the safe operation of the appliance. Firstly, the National Electrical Code, often referred to as the NEC, provides specific guidelines for electrical installations, including the sizing of circuits for appliances. For ranges with a gas cooktop and an electric oven, the NEC dictates different circuit requirements based on the total electrical load of the appliance. The key threshold is 8,000 watts. Secondly, if the range has a total electrical load of 8,000 watts or less, a 30-amp circuit is generally sufficient. However, for ranges that exceed 8,000 watts, a 40-amp circuit is required. This distinction is crucial because using an undersized circuit can lead to overheating, trip breakers, and potentially dangerous situations. Thirdly, to determine the correct circuit size for a specific range, you should consult the manufacturer's specifications or the appliance's nameplate. A nameplate is typically located on the back or underside of the range and provides essential information about the appliance's electrical requirements, including the total wattage. Once you have identified the total wattage, you can determine whether a 30-amp or 40-amp circuit is needed. For ranges with a total electrical load of 8,000 watts or less, a 30-amp circuit is adequate. In this case, you should use 10 American wire gauge wire for the circuit. American wire gauge, or AUG, is a standard system for denoting the size of electrical conductors. The lower the AWG number, the larger the wire's diameter and the more current it can safely carry. For a 30-amp circuit, 10 AWG wire is the appropriate size to handle the electrical load without overheating. Additionally, you should use a 3-pronged NEMA 14-30 receptacle for the connection. NEMA stands for National Electrical Manufacturers Association, and the NEMA 14-30 receptacle is a standard configuration for 30-amp, 120 volts or 240 volt circuits. It has 3 prongs, one for the hot wire, one for the neutral wire, and one for the ground wire. For ranges with a total electrical load exceeding 8,000 watts, a 40-amp circuit is required. In this case, you should use 8 American wire gauge wire for the circuit. As mentioned earlier, a lower AWG number indicates a larger wire diameter, and 8 AWG wire is necessary to handle the higher current of a 40-amp circuit. You should also use a 3-pronged NEMA 14-50 receptacle for the connection. The NEMA 14-50 receptacle is a standard configuration for 50-amp, 120 volts or 240 volt circuits and is designed to accommodate the higher current requirements of larger appliances. In addition to selecting the correct circuit size and wire gauge, there are other important considerations when installing a range with a gas cooktop and an electric oven. Firstly, the circuit should be dedicated to the range only and not shared with other appliances. This is to ensure that the range has sufficient power and to prevent overloading the circuit. Secondly, local building codes may require the installation of a ground fault circuit interrupter or an arc fault circuit interrupter on the circuit. A ground fault circuit interrupter, or GFCI, is a device that detects ground faults and interrupts the circuit to prevent electrical shock. An arc fault circuit interrupter, or FSI, is a device that detects arc faults, which are dangerous electrical conditions that can cause fires. These devices add an extra layer of safety to the electrical installation. Finally, it is highly recommended to consult with a qualified electrician to ensure proper installation and adherence to code requirements. Electrical work can be dangerous, and a qualified electrician has the knowledge and experience to perform the installation safely and correctly. They can also ensure that the installation complies with all applicable codes and regulations. In summary, when installing a range with a gas cooktop and an electric oven, it is essential to determine the correct circuit size based on the appliance's total electrical load. For ranges with a load of 8,000 watts or less, a 30 amp circuit with 10 AWG wire and an EMA 14-30 receptacle is sufficient. For ranges exceeding 8,000 watts, a 40 amp circuit with 8 AWG wire and an EMA 14-50 receptacle is required. The circuit should be dedicated to the range only, and GFCI or FSI protection may be required by local codes. Always consult with a qualified electrician to ensure a safe and code-compliant installation. Now let us delve deeper into the practical aspects of determining the correct circuit size, selecting the appropriate wiring and receptacle, and understanding the safety considerations involved in installing a range with a gas cooktop and electric oven. We will explore the nuances of interpreting the manufacturer's specifications, performing load calculations, and adhering to the National Electrical Code guidelines. Firstly, when determining the circuit size for a range, the most reliable source of information is the manufacturer's specifications. These specifications typically include the total wattage of the range, which is the key factor in determining the required circuit amperage. The wattage rating is usually found on the appliance's nameplate, which is a small metal or plastic tag affixed to the back or underside of the range. The nameplate provides essential information about the appliance's electrical characteristics, including the voltage, amperage, and wattage. Secondly, once you have located the wattage rating, you can calculate the required circuit amperage using Ohm's law. Ohm's law states that current, measured in amps, is equal to power, measured in watts, divided by voltage, measured in volts. In the United States, most residential circuits operate at 120 volts or 240 volts. Ranges are typically connected to a 240 volt circuit, as this provides the necessary power for the electric oven. To calculate the required amperage, divide the wattage rating by 240 volts. For example, if a range has a wattage rating of 7,200 watts, the required amperage would be 7,200 watts divided by 240 volts, which equals 30 amps. This calculation confirms that a 30 amp circuit is sufficient for this particular range. Thirdly, it is important to note that the National Electrical Code allows for some flexibility in sizing circuits for ranges. Specifically, the NEC permits the use of a demand factor, which is a percentage that can be applied to the total wattage rating to account for the fact that the range will not always be operating at its maximum power. The demand factor varies depending on the number of appliances connected to the circuit and the type of appliances. For a single range, the NEC typically allows a demand factor of 80%. This means that you can multiply the wattage rating by 0.8 to determine the adjusted wattage for circuit sizing purposes. For example, if a range has a wattage rating of 9,000 watts, the adjusted wattage would be 9,000 watts multiplied by 0.8, which equals 7,200 watts. In this case, a 30 amp circuit would still be sufficient, even though the range's initial wattage rating exceeded 8,000 watts. Once you have determined the required circuit amperage, you can select the appropriate wiring and receptacle. As mentioned earlier, 10 American wire gauge wire is suitable for a 30 amp circuit, and 8 American wire gauge wire is required for a 40 amp circuit. It is essential to use the correct wire gauge to prevent overheating and ensure the safe operation of the appliance. The wire should be copper, as copper is an excellent conductor of electricity. You should also use a 3-pronged NEMA 14-30 receptacle for a 30 amp circuit and a 3-pronged NEMA 14-50 receptacle for a 40 amp circuit. These receptacles are designed to accommodate the specific amperage and voltage requirements of ranges. In addition to selecting the correct wiring and receptacle, there are several safety considerations to keep in mind when installing a range. Firstly, always disconnect the power to the circuit before beginning any electrical work. This can be done by turning off the circuit breaker that supplies power to the range circuit. Secondly, use appropriate safety gear, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. Thirdly, carefully follow the manufacturer's instructions for installing the range. The instructions will provide detailed information about the proper wiring connections and grounding procedures. Fourthly, ensure that the range is properly grounded. Grounding provides a path for stray electricity to flow back to the source, which helps to prevent electrical shock. The grounding wire should be connected to the grounding terminal on the range and to a grounded metal box or grounding rod. Fifthly, inspect the wiring and connections carefully to ensure that they are secure and properly insulated. Loose connections can cause overheating and electrical arcing, which can lead to fires. Sixthly, if you are not comfortable performing the electrical work yourself, it is best to hire a qualified electrician. Electrical work can be dangerous, and a qualified electrician has the knowledge and experience to perform the installation safely and correctly. They can also ensure that the installation complies with all applicable codes and regulations. In summary, determining the correct circuit size for a range involves consulting the manufacturer's specifications, calculating the required amperage using Ohm's law, and applying the NEC demand factor if applicable. Selecting the appropriate wiring and receptacle is essential for ensuring the safe operation of the appliance. Finally, following proper safety procedures and consulting with a qualified electrician can help to prevent electrical hazards and ensure a code-compliant installation. Let's continue to elaborate on the importance of grounding, the role of ground fault circuit interrupters and arc fault circuit interrupters, and the potential consequences of improper wiring. Grounding is a critical safety feature in electrical systems. It provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and to energize the circuit in the event of a ground fault. A ground fault occurs when a live wire comes into contact with a grounded metal object, such as the appliance's chassis. Without proper grounding, the fault current could flow through a person who touches the appliance, resulting in a potentially fatal electrical shock. The National Electrical Code requires that all appliances be properly grounded. The grounding conductor, typically a green or bare copper wire, should be connected to the grounding terminal in the appliance and to a grounded metal box or grounding rod. The grounding conductor should be sized according to the amperage of the circuit. Ground fault circuit interrupters and arc fault circuit interrupters are additional safety devices that can help to protect against electrical hazards. A ground fault circuit interrupter is a device that detects ground faults and interrupts the circuit to prevent electrical shock. It works by monitoring the current flowing through the hot and neutral wires. If there is a difference in current, it indicates that some of the current is leaking to ground, which could be a sign of a ground fault. The ground fault circuit interrupter will then trip the circuit, cutting off the power to the appliance. Arc fault circuit interrupters are devices that detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when there is an unintentional electrical discharge between two conductors. This can happen when wires are damaged, loose, or corroded. The arc fault circuit interrupter detects the unique characteristics of arc faults and trips the circuit, preventing a fire from starting. The National Electrical Code requires arc fault circuit interrupter protection in many areas of the home, including bedrooms and living rooms. While arc fault circuit interrupters are not typically required for range circuits, they can provide an extra layer of safety. Improper wiring can have serious consequences, including electrical shock, fire, and equipment damage. It is essential to follow the manufacturer's instructions and the National Electrical Code guidelines when wiring a range. Some common wiring mistakes include using the wrong wire gauge, making loose connections, and failing to properly ground the appliance. Using the wrong wire gauge can cause the wires to overheat and melt, which can lead to a fire. Loose connections can also cause overheating and electrical arcing, which can ignite nearby materials. Failing to properly ground the appliance can expose people to the risk of electrical shock. In addition to these safety considerations, it is also important to consider the long-term performance of the electrical system. Using high-quality wiring and components can help to ensure that the system will operate reliably for many years. Regular maintenance, such as inspecting the wiring and connections, can also help to prevent problems from developing. In conclusion, installing a range with a gas cooktop and an electric oven requires careful attention to detail and adherence to the National Electrical Code guidelines. Determining the correct circuit size, selecting the appropriate wiring and receptacle, and following proper safety procedures are essential for ensuring a safe and code-compliant installation. Grounding, ground fault circuit interrupters, and arc fault circuit interrupters are additional safety features that can help to protect against electrical hazards. Improper wiring can have serious consequences, so it is important to follow the manufacturer's instructions and consult with a qualified electrician if you are not comfortable performing the electrical work yourself.